Hello friends, today we are going to see the subject ERTOS, Embedded Real-Time Operating Systems, in which we are going to see the unit 6, that is multiprocessor scheduling. Now, multiprocessor systems follow a tightly coupled characteristics. Or we can say multiprocessor can use a centralized dispatcher or scheduler. When each processor in a multiprocessor system uses an individual processor, scheduling actions by all processors are taken coherently. Scheduler is used on separate processor and it can be divided, decide resource access controls and scheduling criteria independently. So these systems are a coherence. Now multiprocessor systems can use this homogeneous and heterogeneous system. Homogeneous multiprocessor system means all the processor or machines used in a multiprocessor systems are of same configuration. Same configuration in sense of processing power, its storage, and some case even vendors also. While heterogeneous multiprocessor system means all the processor or machines used in multiprocessor systems might follow a separate configuration. Okay. Considering job specification to particular machines, then maintenance of distributed system of these heterogeneous systems requires high processing capabilities because they are considering a job specification of a particular machines. Right? Next to that is task assignment. How task assignment is to be done in multiprocessor scheduling. In case of multiprocessor systems, the application is divided into modules and each module is assigned to separate processor. This binding of module with processor is called as a task assignment. Right? But I say multiprocessor system, the application is divided into modules and each module is assigned to separate process. Okay, this binding of modules processors is called as a task assignment. Most of the hard real-time systems are static as the tasks are already known before the start of processing. So static task assignments can be done, and types like AB offline task assignment and AB online task assignment. Now AB offline task assignment, the system is static and all the tasks that might need processing are known as forehand. Okay, the offline task assignment is done to configure how many processors are required for application or how module allocations will be done, which task goes with which processor. Okay, whereas AB online task assignment, in some cases tasks coming into a systems are unknown and can be generated dynamically. Okay, in AB offline system is a static. Okay, here tasks coming into the system are unknown and can be generated dynamically. For serving this task, online task assignment is used. The online task assignment system checks if system processor can schedule the incoming task or not. It is accepted only if system can serve the task. Getting? So these are the two types: AB offline task assignment, which is the static process, and task might need processing known beforehand. And AB online task assignments, tasks coming into the systems are unknown that can be generated dynamically. Right? And serving up this task is online assignment. Now task assignment can be done with the three strategies. First one is a task assignment based on an execution time requirement. Then task assignment to minimize the total communication cost. Then integration of a task and resource assignment. Now task assignment based on an execution time requirement. In this strategy, the scheduler consider only processing time. If the task neglecting all communication overhead, mostly referred in a communication via shared memory, and in some signal processing task where communication cost can be minimized to negligible. Now second strategy, that is task assignment to minimize total communication cost. In case of scheduling where multiple CPU are required, communication cost increases with increasing number of CPUs. Right? Multiple CPUs are required, communication cost increases with increasing number of CPU. So while doing task assignment, it is observed that number of CPUs required while the location of a module in the application should be done with minimum number of CPUs, which reduce the communication overhead. That is nothing but task assignment to minimize the total communication cost. The next one is the integration of a task and resource assignment. The problem of which processor should be allocated to which task varies based on task requirement of a resource. This strategy looks out for the location of modules in such a way that most of resources required for the completion of tasks are available locally and very few resources are remotely. Okay, these are the task assignments with three strategies. Okay, now in 5 minutes we will revise the all points. Our first topic is multiprocessing scheduling. Right, as I said, multiprocessor system follow a tightly coupled characteristics, means status and workload of all processors can be kept up to date with the low overhead, and multiprocessor system can use a centralized scheduler or centralized dispatcher. That means when each processor in multiprocessor uses individual processor scheduling action by all the processors are taken coherently. Right. And in contrast to multiprocessor system, distributed system are loosely coupled. By keeping all this track of global information such as the status workload of all the processors tedious tasks in a distributed system. As I said, multiprocessor system can use a centralized dispatcher or scheduler. Why scheduler? Scheduler used on a separate processors can decide resource access controls and scheduling criteria independently. So these systems are in coherence. Now again, multiprocessor systems can use as homogeneous and heterogeneous system. Homogeneous multiprocessor system means all the processors used in multiprocessors having same configurations like its power, storage, vendors, right? While in heterogeneous multiprocessor systems, all the processors or machines used are having separate configurations. Or one more point is maintenance of distributed system of heterogeneous systems requires the high processing capability. Okay, this is all about the multiprocessor scheduling. Now, how task assignment is done in multiprocessor scheduling, right? In case of multiprocessor system, the application is divided into module and each module is assigned to separate processors called as a task assignment. Task assignment type, it can be done by using AB offline task assignment, that is the static, and that might need accessing beforehand. And next one is a AB online task assignments, in which tasks coming into a system are known as a dynamically task, or we can say they are the unknowns to the system, and serving of this task is called as a online task assignment. Now this task assignment can be done by using three strategies. First one, based on a execution time requirement. Okay, it consider only processing time of the task, neglecting all communication overhead. Most of it refers in a communication via shared memory. Second one is to minimize the total communication cost. Right, means scheduling where multiple CPUs are required, communication cost increases with increasing number of CPUs. So while doing a task assignment, it is observed that number of CPUs required for allocation of a module in an application should be done with minimum number of CPUs, which reduces the communication over. And third strategy, that is integration of a task and resource assignments. And the problem of processor should be allocated to which task varies based on a task requirement of a resource. This strategy looks out for allocation of modules in a such a way that most of the resources required for the completion of a task are available locally and very few resources remotely. Okay, this is all about multiprocessor scheduler. Thank you.